confused by the last set of slides, we're going to pick up here with several examples. So during these examples, there's a lot of points where you can just click a button and the next thing will come up. Since you're watching this on a video, hit pause so you can do that on, after you hit pause, they will just come up. I'm going to try to wait a few seconds to give you time. All right, so let's go through about 4 examples of ionic equations, and I'll keep the step-by-step off to the left, as you can see. So let's look at this example. All right, so this is the molecular equation that we've been going through. So the first step is write the balanced molecular equation. All right, and remember you can review this. The next step, okay, is to determine the types of substances. So I put the solubility rules here so you can see. So if we look at these 4 substances, potassium iodide, lead-2 nitrate, lead-2 iodide, and potassium nitrate, right? We look at each one of the solubility rules. So these are all ionic compounds. Potassium iodide has an alkali metal, rule 2, so it's soluble. Lead-2 nitrate is a nitrate. All nitrates are soluble. Lead-2 iodide, okay, is an exception because iodide is a halide, but lead compounds are insoluble. And then potassium nitrate, we have rule 1 and rule 2 says it's soluble. So if we go to the next slide, you can see what we've done is classify the types of substances. The next thing we do is we write the total ionic equation. So in order to do this, we're going to take the soluble ionic substances, these 3, and we're going to write them as ions. All right, so I'm going to go ahead and click this. Okay, so to write the ions, soluble ionics are written as ions. So each of the 4 substances, this is what we're going to do. So the ions will break up. Notice that there's 2 nitrates here. All right, this one we'll leave alone. So now putting this together here, the total ionic equation is going to look like this. So the potassium iodide, as we said, notice that since there's a 2 here, we distribute it through. Since there's a 2 here, we distribute that through as well. All right. Now, spectator ions are things that are the same on both sides. So you can see the potassium and the nitrate are exactly the same on both sides. So if we just cancel them out, and then what the net ionic equation is just if we rewrite it without these spectators. There you go. So those are the steps. All right, so let's go to another one. All right, so potassium carbonate and sodium chloride. So this is where you can hit pause just to make sure you can write the balanced chemical equation. So I'm going to count. All right, so there's the molecular equation. All right, the next step is determining the types of substances for each of these 4. All right, so I'm going to count in my mind, give you time to hit pause, try it on your own. All right, so if we look at the types of substances, potassium carbonate is soluble because, again, you have to look at the solubility rules. I can't get them on the screen here. All potassium compounds are soluble. Sodium chloride, sodium compound, potassium compound. Okay, the next step is we're going to write the total ionic equation. So I'm going to give you a minute, try that on your own. All right, total ionic equation will be, drum roll. All right, so all of these are broken up. Notice it's 2 potassiums, it's not a K2. That 3 stays there because it's part of the ion. 2 NAs, 2 Cls, 2 NAs, a CO3, 2 Ks, and 2 Cls. Now we're going to cancel out the spectators. This one you don't need quite as much time to pause because just cancel out anything that's the same on both sides. So if we cancel out the spectators, in this case, everything's a spectator. So what does that mean? That means the net ionic equation is there is no reaction. So you can see from this example that we can go through this process so we can say, oh, potassium carbonate and sodium chloride, if they did react, this is what would happen, but they actually don't react. You start off with 4 ions in solution, you end out with ions in solution. All right, another example. All right, more examples. So here we have an acid. So again, write the molecular equation. All right, so hopefully you came up with that as the molecular equation. Again, the process we went through on a different slideshow, the one called types of equations. Now, to determine the types of substances. So here we have an acid. So you want to look in that list to see if it's on the list of strong acids. So look at the types of substances. Right, types of substances. There's the reaction and, okay, this is on the list, so it's a strong acid. This is an ionic compound. If you look at the solubility rules, you'll find out hydroxides tend to be insoluble. Water's covalent, so we don't look at the solubility rules at all. And then magnesium chloride, chlorides are soluble except with silver, lead, and mercury. That's magnesium. So now let's go through writing the ionic equation. Remember, we break the soluble ionic substances, which would be the magnesium chloride, and strong acids, the hydrochloric acid, into ions. Everything else we leave alone. I'll give you a minute. All right, so the total ionic equation is going to look like this. So the strong acid is broken into ions. The insoluble we left alone. The covalent we leave alone. And the soluble ionic break into ions. I think you can see what the spectators are, but I'll give you a few seconds. Ready? That's right, the chloride is the only spectator, and so then the net ionic equation would be, there you go, that's the net ionic equation. And I believe there's one more example. All right, so this incorporates a decomposition. I'll explain how that works. So once again, first thing you want to do, write the balanced chemical equation. This is where you're going to use your nomenclature and that last set of slides. So I'm going to wait a moment before I hit the button so you can hit pause on the video and try it on your own while my dogs bark in the background for your musical enjoyment. All right, so that should be your balanced chemical equation. Hopefully you came up with acetic acid, acetic, right, from acetate. So that would be acetate, right? And calcium carbonate, and then that whole bit. Now, if we look at this one for just a moment, remember those decompositions that I gave you a few slides back, but I'll remind you right now, these ones. This was actually, I think, in the last set of slides. You need to memorize these four substances, how they decompose. If you see one of these as a product, you need to break it up into what it decomposes into. So you can see in the last reaction, carbonic acid was one of the products. So if we go back to the molecular equation, right, since the carbonic acid decomposes, we're going to change that. So now that is the molecular equation. So you just have to look out for those and ask yourself, does one of my products decompose? Have that list memorized. Okay, now we're going to go through the types of substances. So I'll give you a moment to do that. All right, so there's the reaction and ready. The types of substances. Calcium carbonate is ionic, but carbonates are insoluble. That's an acid. It's not a strong acid, therefore it's weak. All acetates are soluble, so except for silver acetate, so this is soluble. These two are covalent compounds. So then the next step is to write the total ionic equation, and total ionic equations, we break up soluble ionic substances and strong acids into ions. So here you go, give you a minute. Right, total ionic is going to look like that. So the only thing we do is break up the calcium acetate. And then we're going to cancel out the spectators. And you'll see in this case, there are no spectators. So the net ionic is going to be the same as the total ionic. All right. So I've given you an example of one that forms a solid, a no reaction, where we form a covalent compound, and where there's a decomposition. So The background for experiment 8 in the lab manual has several examples. You should now be able to do homework 9. So when you do homework 9, that's actually a couple of sets of slides. All right, there is the chemical equations and balancing, the types of chemical equations, and this set. I would suggest that while you're working on these things, have the periodic table, of course, solubility rules, your list of strong acids, the ionic equations flowchart if you find that helps. And then I didn't finish the slide apparently, but any nomenclature stuff, I should say any nomenclature stuff. So I'll fix that on the slides, but I'm not going to fix it on the video. Any nomenclature stuff you need. So give yourself some time on this homework, and you know how to reach me as you're going through this. Best of luck to you, and hope you're all well.